Hello friends, today in this video we are going to see two network domains having EIGRP routing protocol as its internal routing are going to uh, interlink between them by the use of BGP routing protocol. So for the easier understanding, I am just taking the same topology as I have used in my previous video, where two OSPF network domains get interlinked by BGP routing protocol. So before I start configuring the EIGRP, let's just test the ping report and keep it as a reference. As we proceed further, we will see. So first we'll go to PC0 and ping this PC1. Ping 192.168.1.66. Destination host unreachable. Okay, we'll keep it as a reference. Now here we'll start configuring EIGRP. So let's go to router 0. So router EIGRP ESN number is 30, and here we have to advertise the network uh, in which my interfaces uh, exist. So first network is 192.168.1.0.0.0.63, and the next network is 10.0.0.0 and the 0.0.0.3 and the no auto summary. So after router 0, we'll do the same thing for the router 1. So router number 1, so router EIGRP ESN number is 30, and the network connected are first is 192.168.1.0.0.0.63. The second network is connected to its serial port 10.0.0.4, 0.0.0.3, and the no auto summary. So router 0 finished, router 1 finished. Now we have to configure router 2, and this router 2 is the edge router. So here two routing protocol will be there. One is the EIGRP, which is for the internal routing purpose, and the one will be the BGP for the external routing protocol. So let's first do the this EIGRP router number 2. Now config T router EIGRP ASN number 30. The network connected are network 10.0.0.0.0.0.3, and the network 10.0.0.4 0.0.0.3, no auto summary. IP EIGRP neighbors. So it has to neighbor 10 dot this 0.1 and the 0.5. So it has two neighbors 0.1 and the 0.5. So that means our neighborship has been created. Now we can check the ping test again from PC0 to PC1. So PC0 okay. So we are going to ping to the destination PC number 1, which IP is 192.168.1.66. So pinging. No, it's pinging. And similarly we have to do for the second network domain, PC number 2 to PC number 3. So for refresh also, let's try to ping from PC2 to PC3. Ping 192.168.2.66. Destination host unreachable. Okay, we'll keep it as a reference. And next will be this. Let's now let's go to router number 5 to configure the EIGRP for internal routing. So router number 5. Enable config T, and the first network which is connected to its gig port, first router EIGRP, ASN number is 50, and the first network is connected to its gig port. So 92.168.2.0 and the next network is connected to its serial port, so 10.0.0.16 and 0.0.0.3 the no auto summary exit. So after router number 5, we have to configure for the router number 6. So here enable config D, and you open the router EIGRP asset number 50, and the network, the first network is 192.168.2.64 0.0.0.3 and the second network, it's the serial port having the network IP of 10.0.0.20 and the 0.0.0.3 and the no auto summary. So here router 5 and router 6 configuration is finished. Now here also router 4 is the 8th router, so there also two routing will be there, routing protocol will be there, for one for internal purpose and one for external purpose. So let's go to router number 4. So router number 4 and enable config D router EIGRP ASN number is 50, the network are this 10.0.0.16 0.0.0.3 and the second network is 10.0.0.20 and 0.0.0.3 the no auto summary. Get so IP EIGRP neighbors. Here also two neighbors 0.17 and 0.22. So here is the router 4 and the 0.17 and the 0.22. So here also neighborship has been created. That means the internal routing we can check now whether it has been accomplished or not. So we have to go to PC2 and ping to the PC3. PC number 2. So let's check ping to the PC number 3 having the IP address 2.66. So before it was destination host unreachable, now it's pinging. That means our internal routing for both the two network domains are finished. Now again let's check now this is belong to the network number 2. Now we will try to ping from this to network number 1 PC0. So ping PC0 IP address is 192.168.1.2. It says destination host unreachable. Let's also try to ping to the PC number 1. With the IP address of 1.66. It will also say destination host unreachable because internal routing is finished, but the external routing is not yet been done. So the router has no idea how the outside world it has to go. So for that purpose, we need to create the BGP. So to get BGP, let's do the BGP routing protocol at the BGP router. So router number 3. So router number 3. Router number 3. Enable config the network. Wait. Number 3, router number 3. So router BGP ASN number is 100 and the network not network. We have to create the neighbor first neighbor directing at the network number 1 10.0.0.9. 10.0.0.9 is belong to ASN number 30, and similarly another neighbor is directing at the network number 2. So 10.0.0.14. So 10.0.0.14 remote ASN number 50. It. So here we have introduced BGP and we have defined the neighbor. So at the edge router also we have to open the BGP routing protocol and define a neighbor. So let's go to router number 2. Config the router BGP ASN number 30. So neighbor is directed at the BGP router is 10.0.0.10. 10.0.0.10 and its remote ASN number is 100. So it says neighborship has been developed. Let's check here. So IP BGP neighbor. So it says BGP neighbor is 10.0.0.10 having the ASN number of 100. And so BGP BGP summary. Here also from this command also we can see this 10.0.0.9 is our local BGP IP having the ASN number of 30, and its neighbor is 10.0.0.10 having ASN of 100. So for router 1 we have for this router number 2 finished. So let's go to router number 4, which is the edge router for the network number 2. Router number 4. Okay, here config T and router BGP having ASN number of 50 and its neighbor which is directed to the BGP router is 10.0.0.13. So 10.0.0.13 having remote ASN of 100. So it also say neighborship has been created. Jet. But here now we have this. Let me bring back to the main screen. Here we have this also configured this external routing protocol also and the internal routing protocol also, but these two are still unknown to each other. So here we have to bring the internal routing protocol known to the external routing protocol. Similarly, the external routing protocol also has to be known to the internal routing protocol. For that we have to do the redistribution. So let's go to router number 2. So config T and let's first go to router number this router BGP its number is 30 and redistribute the EIGRP having ASN number 30, right? Exit. And before I do redistribution of the EIGRP into the BGP, here one thing we should know is that this EIGRP is based on the interface matrix, because from that interface matrix it will calculate the link cost. So the lower the link cost, higher the chances for the link to be the successor, or you can say the best part. So so we have the metrics like bandwidth, delay, load reliability, and MTU. But also I have already said in my explained in my EIGRP video, by default we take bandwidth and the delay as the matrix K1 and the K3. But when we have to do the redistribution process, we have to mention all the values for all the matrices. So here this external route, this is the BGP route connecting from the S router to the BGP router. The interface, this matrix, it has to be provided to the EIGRP to let it know when it tries to go from the internal to external world, what are the matrices it has to go, because based on that matrices it will develop the route path, because EIGRP created the root part based on the matrices. So let's see this serial port, this matrix value to router number 2. This and also one more thing, this is the serial port. So serial port has a bandwidth of 1.544 Mbps. So let's see from here also. So IP interface, no, so interface SE 0/2/0. So serial port has a bandwidth of 1.544 Mbps. In kbps is 1544, and delay is 20,000 microsecond, which can be in terms of tens of microsecond will be 2000, and the MTU 1500, and reliability is 255, is 100% reliable, and the load, its load value can be 1 to 255. So 255 is fully loaded. Okay, so based on this value we have to config T and the router EIGRP 30. So we have to redistribute our BGP ASN number 30 into it. Here we can put also some question mark if we have any doubt. So it asking for matrix. So matrix, first we have to put the bandwidth to 1544. It should be in kbps. Then the this delay 20,000 microsecond, but in redistribution we have to write in tens of microsecond. So 10 time of so 2000, this 20,000 in terms of tens of microsecond, it can be written as 2000. So 2000 into 10 will be 20,000. So 2000 is the delay, then reliability is fully reliable 255, then the load is 1, MTU 1500. Okay, here I have redistribute both the EIGRP and the BGP to one another. So the number so similarly we have to do for a router number 4. Here, so interface SE 0/1/0 0 and the config T and the first router EIGRP having the ASN number of 50, and the redistribute BGP this 50 matrix is 1544, 2000, 255, load 1, and the MTU 1500, the exit, then router BGP 50 redistribute EIGRP 50. So we have hello the two router know to know each other, both internal and external. We share the information between them. So now let's try to ping now from PC2 to PC0 and PC1 in the from network 2 to network 1. So PC number 2. So 1.2, let's first try to ping. It's now pinging. 1.66, this is also pinging. So here also we have shown two network domains having EIGRP as its internal routing protocol can communicate with one another with the help of BGP. So in my next video I will try to make a hybrid one, in which one will be OSPF, one will be EIGRP, and let them communicate by the help of BGP. So that is for today's. So thank you friends.